if I may say, old colleague and friend, Professor Marco Passarotti from Catholic University in Milano. Actually, Marco is a student of Professor Padre Robert Busa, and I should say that our context with the Professor Busa go back to the mid-60s of the last century, when Padre Busa was a guest in Prague at, I would say, the first corpus and computational linguistics conferences in Prague, in a small place near Prague. And that was actually our first meeting with Padre Busa. And since then, we have seen him very often. And he was really a very nice person to meet and to talk to. So you see, our contexts are really very long. The most recent news, I would say, we got from Marco was that he became the principal investigator of one of the prestigious ECR grants. So I think that his lecture today will be somehow connected to the topic of that grant, as far as I can understand. So, Marco, the floor is yours.
Thank you very much, Eva. Thank you very much, everyone at UFAL, for this invitation. Let me share the screen so you can see my slides. Here it is. Now you should be able to see the slides. And now I will go full screen. Here it is. You should be able to see my slides. If Magda, is it okay?
It's perfect.
Okay. So thank you very much for this invitation. As you know, I always love to, let me say, come to Prague, even if only virtually this time, waiting for better times to come. And I was happy to see many friend faces among the participants. And well, as Eva said, this time I won't talk only about tree banks, but I will talk mostly about linked data for linguistics. So we will see words, classes, branches, and links, as the title says. And as you can see in the subtitle here, we will talk about interlinking, which is a hot word in my talk today, interlinking resources for Latin in the linguistic linked open data world through the LiLa knowledge base, which is the real achievement of this ERC project, which is in its third year now. So this is the overview of my talk. I will provide you with some basic introduction and fundamentals, mostly for those of you who are not familiar with linked data. And we will talk about the mission and the motivation of LiLa and its architecture. And then we will go live, hopefully that everything will go smoothly, talking about what LiLa is now, and we will see a number of lexical resources, textual resources already linked to LiLa, and then I will try to run this text linker, which is a tool that automatically links a textual resource to the LiLa knowledge base. So let's start from what is LiLa. Well, before speaking about what is LiLa, let me say why LiLa. LiLa starts from a research question that reflects a state of affairs, because it's a matter of fact that over the years, the decades, we have built and collected for Latin, but for many other languages, of course, a lot of textual resources like corpora, lexical resources like lexica and dictionaries, and natural language processing tools. At least for Latin, most of these resources and tools are currently scattered and unconnected. So people get crazy to find the resources and tools, at least for Latin, but not only for Latin. And once they have found the resources, they have to learn different query languages, data formats, tag sets, annotation criteria. So with the LiLa knowledge base, what we are doing is to resolve this situation by applying the principles of the linked data paradigm to linguistic resources for Latin to make them interoperable. So we are building the LiLa knowledge base, which is defined as a collection of multifarious interoperable linguistic resources for Latin, described with the same vocabulary for knowledge description, which means that they are described by using common data categories and ontologies, which is a technical way to say that they speak the same language. And in this way, they can be interlinked and then they can interact. And well, some other times, in some other occasions, the title of my talk was Prefixes Matter, because there is a difference in the prefix of what an infrastructure is about. And the prefix here is an infrastructure, which is a collection of resources that are stored in one place, like Clarin, and what LiLa and more generally speaking, the linguistic linked open data community is trying to achieve, which is interoperability between distributed resources that don't have to be stored necessarily in one place. And for those of you who are interested, on Thursday afternoon, this evening, there will be a Clarin Café explicitly dedicated to linguistic linked data. So just a few words about linked data. Let's see what are the 4 basic linked data principles. Just to be fair, you know about this acronym that is much used today: findable, accessible, interoperable, and reusable. And when I designed the LiLa project, the LiLa proposal for the ERC, believe me, I didn't know about the FAIR principles. But while preparing for the ERC interview in Brussels, I suddenly discovered that LiLa was a perfectly fair project, because its architecture would have made the data of the linguistic resources findable, accessible, interoperable, and reusable. And in order to become fair, to make the data fair, the linked data principles are very fitting. And the first one of these principles is that you have to use URIs for things. URIs are uniform resource identifiers. Basically, they are unique identifiers like your genetic code that identify uniquely things. And the things in our world are words, entries in a lexicon, a token in a corpus. Each of the components that you will see today are identified uniquely by its genetic code that is called a URI, that then becomes a URL when you use a protocol to distribute URIs in order to allow people to look up things, for instance, on the web using a protocol like HTTP. And then the third principle states that you have to use web standards to represent and query the metadata, such as RDF and Sparkle. And I will not enter the details here, but an important aspect about RDF is that Resource Description Framework is the data model that is behind the representation of resources, and not only in terms of linked data. And the basic idea of RDF is that of triples. You represent things and information by triples made by 3 things: a subject, an object, and the relation holding between the subject and an object. For instance, in this case, I can be a subject, Marco Passarotti, and you can be an object, one of you can be an object, Eva can be an object, and there is a relation between us, which is colleague of. So Marco Passarotti is proudly colleague of Eva Aichova. So there are 3 elements: a subject, an object, and the predicate that connects these 2 elements, and that is technically called a property. Third, include links to other URIs. So you connect the different things that are uniquely identified by URIs. And there are some benefits of applying linked data and principles of linked data to linguistic resources. I will be very brief here. First of all, there is a benefit of representation and modeling, because RDF with this triple representation of information is a very good data model to represent what we are dealing with today, every day, standoff annotations, dependency parsers, and so on. There are already some protocols and data models that support structural interoperability. So the things that can interact in terms of structure, for instance, on the web, which HTTP. And this is very important, there are already available vocabularies, ontologies, data properties, a kind of common language that supports the conceptual interoperability between distributed resources, which basically make it possible to understand how to use and most of all interpret semantically the URIs. Federation, you can combine data and metadata from physically separated repositories. During my talk, you will often listen to me saying something like distributed resources, because this is really one of the added values of linked data. Dynamicity. Each data provider can always provide access to the most recent version of the resource if the resource is stored locally from the data provider. Ecosystem. There is a large, growing and active community which is struggling to build common tools, practices, ontologies. Every week I have a number of calls about stuff like how can we represent inflectional morphology or derivational morphology in terms of shared ontologies and vocabularies. So, this given, let's see the basic architecture of the LiLa knowledge base, which is very simple, and it is a lexically based architecture, because we started from the assumption, which is a more almost trivial assumption, that everything in LiLa deals with words. So lexical resources provide information about words, which are represented in terms of lexical entries. You open a dictionary and you find lexical entries. Textual resources are made of occurrences of words. So the texts are made of occurrences of tokens. And natural language processing tools process words and provide NLP outputs. So you see a double arrow here, because the output of some NLP tools, namely a tokenizer, are tokens that then are the input of other NLP tools, for instance, a part-of-speech tagger. So the good point is that for Latin and for many other languages, we already have a lot of lexical resources, a lot of textual resources, a lot of NLP tools. So the objective and the challenge of LiLa is to make them interact. And the idea behind the LiLa is that we make them interact through lemmas. So lemmas are the elements that make tokens, lexical entries, and the output of NLP tools interact. So for instance, you can search for all the occurrences of a specific lemma in a number of distributed textual resources, distributed corpora that are linked to LiLa. Or you can search for all the occurrences of those lemmas that exhibit some specific lexical properties that are described in some specific lexical resources. So, LiLa is a mere reflection of what is there. Reflects the annotation granularity of your resource. We don't make any data enrichment or further analysis, but we can help you to enrich your metadata, because one of the requirements to connect a resource in the LiLa knowledge base, it's quite clear, is that it has to be lemmatized. And last year, as you know, because UdiPipe was the winner system, we launched the EvaLatin competition in order to make the point about the state of the art of automatic lemmatization and part-of-speech tagging for Latin. And I must say that we were pretty happy for the results, and we thank you very much for building UdiPipe. So at the end of this talk, I will show you a tool that we built in order to help our colleagues who build some textual resource for Latin, which is not lemmatized, to lemmatize it automatically. Of course, to enter the LiLa knowledge base, it will be good that the resource, the textual resource, is not only lemmatized, but also part-of-speech tagged, ideally using the universal dependencies tag set. And the best it will be that it is also online, which means that, for instance, for the textual resources, each token is already assigned a URI that is shared on the web as a URL. If the resource is not in this condition, we can provide help to make that the resource is lemmatized, part-of-speech tagged, and then published online. So now let's move to LiLa now, so to the LiLa Lemma Bank and to textual resources, lexical resources and textual resources. Now, the LiLa Lemma Bank. As you have seen, lemmas play a fundamental role in the LiLa knowledge base. So basically, we spent the first 2 years of the project building a big collection of lemmas for Latin, which is called by us the Lemma Bank. And in order to build this collection of more than 140,000 lemmas for Latin, we had to represent it with some shared ontology. And we chose this de facto standard for publishing lexical data as linguistic linked open data. This is the Ontolex Lemon model. So I will not enter the details here, but what is important to know here is that one big and important class of the Ontolex Lemon model is the lexical entry. And because lexical resources are made of lexical entries. And a lexical entry can have one or more lexical forms. So for instance, for English, for the lexical entry to go, you have a number of forms: goes, going, gone, went. And one of these lexical forms, this is a class, one of the lexical forms is the so-called canonical form. The canonical form is the form that is canonically and conventionally chosen to represent the entire lexical entry. Nothing but the lemma. Of course, there can be different criteria to select which is the canonical form, and we reflected this in the Lemma Bank. So we spent the first 2 years of the project by building this. So a big collection of canonical forms for Latin that can be used then in order to make all the distributed resources interact. Then indeed, the bottom part of this model, there is the semantic part. So a lexical entry has a number of lexical senses. And a lexical sense is the lexicalized sense of. So it is the lexicalization of a more general lexical concept, which is evoked by a lexical entry. And I'm sure that many of you can recall in this terminology, some terminology taken from other theoretical frameworks. So a lexical entry evokes a lexical concept and has a number of lexical senses, which are the lexicalization of the lexical concept. We will see this now by looking at how we modeled a number of linguistic resources, and we start from lexical resources in the LiLa Lemma Bank, in the LiLa knowledge base, using the Lemma Bank. So the Lemma Bank includes more than 140,000 lemmas for Latin that are called canonical forms reflecting the Ontolex Lemma model. And the source for this, for the Lemma Bank is the Lemlat morphological analyzer for Latin, which is a widely used morphological analyzer. So now let's start from this lemma, admiror, which in Latin means to admire, to respect. This is the URI for admiror, so the uniform resource identifier. And from admiror, we will see these 1, 2, 3, 4, and 5 lexical resources that are currently linked to LiLa. So a derivational lexicon called word formation Latin, a polarity lexicon used for sentiment analysis task, which is Latin affectus, an etymological dictionary for Latin published by Michael Devan, a valency lexicon, which is called Latin Vallex, that reflects very much your Prague Vallex lexicon, but it is much smaller, unfortunately, and a manually checked subset of the Latin wordnet. So let me click here, and let me hope that everything will go well. So this is the entry for admirer in the Lemma bank. So this is a canonical form, and this is its uniform identifier. Everything is represented in terms of triples following the RDF data model. So here you see a number of triples. This is the subject. These are the properties, so the predicates, and these are the objects. So this subject with this URI as part of speech, this is the property, which pertains to the vocabulary of the LiLa ontology, so an ontology that is built specifically for LiLa, as part of speech, object, verb. So this URI as part of speech, verb, as prefix, add. Now, let's see it graphically, and let's start from here. So imagine this is the canonical form, so the entry for the Lemma bank for the lemma admirer, which has also another written representation, admirer. And now from here, we will see a number of lexical resources that are currently linked to LiLa. So you see here that there is a triple where this is the subject, this is the object, and this is the property. So what is this subject? This is a lexical entry, so a lexical entry, while this is a lexical form, this is a lexical entry of the word formation Latin resource, which is a derivational morphology lexicon, which is connected to the Lemma bank by this property, which is canonical form. So the canonical form for this lexical entry is this one. Here, on this side, you have the lexical entry for a specific lexical resource. So each lexical resource is made of a number of lexical entries, each of which is connected through the property canonical form to its lemma in the Lemma bank. So let's see how this is represented. So admirer is the source of a number of derivatives. So for instance, admirator. So this information is in the WFL resource, in the word formation Latin resource. And it is modeled like this in the LiLa knowledge base. So a lexical entry, admirer, is the source of a relation between the lexical entry and another lexical entry, which is admirator, which derives from admirer. And this derives using a specific word formation rule, which is the word formation rule that builds admirator from admirer involving a specific suffix, which is store. And if I click here, you see that there is a property that connects the subject, which is the word formation rule, with the suffix that this word formation rule involves. And around these are the connections to all the other word formation rules that in WFL make use of Tor. So for instance, the one that creates dextrator, which, well, actually it is this one, sorry. Here it is. Here it is. You see here that to Tor are connected all the lemmas in the Lemma bank that have this suffix. So what can you do here? You can run a query such as, give me in all the corpora linked to LiLa, all the occurrences of words that have an entry in WFL, which are the source of a word formation rule that involves a specific suffix. So basically, all the words that are created with a specific suffix in WFL. Well, so you are using distributed corpora and you are using a lexical resource. Actually, there is something more, because let's get back here to admirer and admirer. And let's see the lexical entry for admirer in another resource. That is the Latin wordnet and the Latin vallex. So this is the lexical entry for admirer in Latin wordnet and Latin vallex that are represented together. So these lexical entries connected by canonical form to the lemma in the lemma bank. And this lexical entry evokes a number of valency frames, which are modeled as lexical concepts in the Premon model, which is a model that is used to represent predicate argument structures. So in this valency frame, the verb admiror has two semantic roles, an actor and a patient. I don't have to explain you what is the semantics of actor and patient here, because we follow the semantics of actor and patient that is in the tectogrammatical layer of annotation in the Prague dependency tree bank. And from here, you can move to all the actors for all the valency frames that are in Latin vallex. So for instance, they are the actor of the lemma abeo for this specific valency frame. Well, why did we jointly represent the vallex, the Latin vallex information, which is made of valency frames assigned to lemmas, and together with the wordnet? Because we had to find a way to connect a specific valency frame assigned to a specific lexical entry, its sense. So the best way we found to assign and to map a valency frame to a sense was to map the valency frame to one of the synsets, or the only synset, that is assigned to a lexical entry in the Latin wordnet. So we are doing the work together. We are representing the two things together. And in Premon, in the Premon ontology, this is represented by a conceptualization. So this valency frame has a specific conceptualization. And this conceptualization makes it possible to create a mapping with the sense, with this sense. So it seems to be difficult, but it's not. This is the lexical entry for admiror, both in word formation, in Latin wordnet and in the Latin vallex. To this admiror are assigned a number of valency frames, for instance, this one. And to this admiror are assigned a number of synsets, for instance, this one, which means regard highly, think much of it. And this valency frame is connected to this sense, to the sense represented by this synset. And this mapping is represented to the conceptualization of the valency frame, the conceptualization of the wordnet synset, and the mapping between the two. Of course, this synset is evoked by other lemmas, like for instance, estimo and amo, and each of these lexical entries of the wordnet is linked by canonical form to their lemma in the lemma bank. And from here, from the lemmas in the lemma bank, you are connected to all their occurrences in all the textual resources. So you can run a query like, give me all the words in all the corpora linked to LiLa that have a specific suffix, and you make use of word formation Latin, and that have a meaning that is represented in one specific word synset, which is connected to a specific valency frame that has, for instance, an addressee functor, and collect all of them. So you are using information from different textual resources, a derivational morphology lexicon, a wordnet, and a valency lexicon. The good thing is that we already have all these resources. All that we have to do is to make them interact. So let's get back again to admiror. To each lemma, derived lemma in the lemma bank, we assigned, by using this as base property, its base. And the base node is nothing but a connector of all the words in the lemma bank that share the same lexical base. So for instance, here there is miraculum, and here there is miracula, which is the plural, and nimirum, and miraculus, which is the masculine one, and mirifico, and so on. So just from the lemma bank, you can run a query such as, give me all the occurrences in all the textual corpora connected to LiLa of the lemmas that share this specific base. So you are using derivational morphology information. And among these bases, there is one where I would like to focus on, which is Mirus. So now let's focus on Mirus. And let's see from Mirus how we modeled two other lexical resources. The first one is this one. So this is a lexical entry, which is connected by canonical form to the canonical form, so the lemma in the lemma bank. And this lexical entry is a lexical entry of the Brill, as you can see it in the bottom left part of the screen, of the Brill dictionary, etymological dictionary of Latin and Italic languages published by Michael Devan. So when you open, imagine that here in the lexical entry, you open the dictionary. And when you open the lexical entry for Mirus in the dictionary, you find an etymology. And this the vocabulary representing the etymology is taken from a specific ontology that is used to represent etymologies in lexical entries. So the etymology of Mirus, if you open the dictionary by Devan, is made of two etyma. This one, which is the Proto-Indo-European root for Mirus, and this one, which is instead the Proto-Italic root for Mirus. But there is something more. If you open the lexical entry in the dictionary, you won't find only two roots, the Proto-Indo-European and the Proto-Italic one, but also the fact that the Proto-Italic root comes after the Proto-Indo-European root comes before the Proto-Italic one. So the Proto-Indo-European root is the source of an etymology link whose target is the Proto-Italic root. So this is the Proto-Italic root, which on its side is the source of an etymology link whose target is the Latin word. So you move from Proto-Indo-European to Proto-Italic, and finally to Latin. And the Latin word is connected to the lemma in the lemma bank, and from here to all the textual corpora. One of my dreams is that to this Proto-Indo-European root are connected in the linked data word all the words that make use of that Proto-Indo-European root in all the Indo-European languages, or all the languages that make use lexically of this Proto-Indo-European root. Now let's focus again on Mirus and let's see the last lexical resource, which is a polarity lexicon. So everyone wants to do sentiment analysis today, so we built a polarity lexicon called, as you can see in the bottom left of the page, Latin affectus. So Mirus has a prior sense, as this prior sense as polarity. This property as polarity is defined in a specific ontology, in a specific vocabulary for knowledge representation that is called MARL. And in particular, Mirus has a prior polarity positive, and around positive are connected all the words in the Latin affectus lexicon that have positive polarity. What can you do here? You can search for all the occurrences in all the textual corpora connected to LiLa of lemmas that have a lexical entry in the Latin affectus with a prior sense positive. What are you doing? You are making all the textual resources and a specific lexical resource, a polarity lexicon, interact, which is exactly what is the aim of LiLa, linking Latin. Now let's get back to the presentation. We have seen a number of lexical resources. Now, as you know, basically I'm a tree banker, so I would like to show you how we link textual resources, and in particular tree banks. I perfectly remember when I came for the first time in Prague in 2006, and some of you asked me, how big is your tree bank? And I answered in a very shy way, something like, well, it is something like 5,000 nodes. I was just starting, so I'm glad to see that today the Index Domesticus tree bank has grown so much, also thanks to one collaborator of mine, Marinella Testori, who is the greatest annotator of Thomas Aquinas ever, thanks to her. God bless her. So this is one of the analytical trees for the Index Domesticus tree bank. Unfortunately, I found that there is a mistake here. This is not an adverbial, but it's an attribute. So this must be an ATR. And we will focus exactly on this part. So medicina here is the subject of this verb, excluded, and it is modified by a relative clause whose head is operator. And we will see also something about the subordinating conjunction sicut, because like all the other tree banks, also the Index Domesticus tree bank has moved since the first version of universal dependencies to the universal dependency style. So we will see how we included and represented the relations between nodes in a tree bank in the LiLa knowledge base. So we will focus on the token medicina. So it is this token, the subject of excluded and modified by operator, modified by operator as the relative clause. So medicina, which means medicine, the healing art, surgery, has this specific URI, which says that it is the word number 11 of a sentence taken from the fifth work of Index Domesticus, which is Summa contra Gentiles, first liber, first book, first chapter, number 6, and so on. So you see here all the triples of medicina. Let's move to the graphical visualization. So this is the token medicina in the Index Domesticus tree bank. You see in the bottom left part of the screen, it's a specific URI. And medicina is connected by this relation as dep with the universal dependency relation and subject that connects medicina with excluded, where excluded is the head of medicina. In particular, medicina depends on excluded as its nominal subject. And of course, here you can link to all, let me see which is the one, this one, to all the nominal subjects in all the Index Domesticus tree bank. So here you will be linked to all the connection nominal subject, like for instance, this one. This one which connects, for instance, guttur with meditabitur in one of the sentences of the Index Domesticus tree bank. I will not enter the details here, but consider that each of these tokens is for each of these tokens, there is information about its reference in the Index Domesticus corpus. So where the token is in the text, in which book, in which chapter, and so on. And each of these tokens is connected via the property as lemma to its lemma in the lemma bank. So with this violet nodes, you are in the lemma bank. So these are canonical forms. So meditabitur is connected to meditor, and guttur is connected to guttur, and medicina is connected to the lemma medicina, and so on. And from here, you can move to all the textual corpora that are linked to LiLa. Now, let's get back to the representation of subject in the various annotation styles of the Index Domesticus tree bank. So here we have seen here the universal dependencies relation. Now let's focus on the SB, the subject relation that connects in the Pragian style, as you can see here, in the Pragian style, connects medicina with excluded. If we get back to here, we will see that medicina is the dependence of excluded with the universal dependency relation and subject, and with the dependency relation SB according to the original style of annotation of the index Domesticus Tribank. So you have both representations in one modeling. Now, here we are. Now, let's move to the text linker, because one of the questions is, well, I have a very nice corpus, but I don't have lemmas. So what we did was to build this text linker where you can just put your text, paste your text here, and then you will have the lemmatized text in output. Well, we tested a number of tools, and finally we found that the best one was UTpipe, that we retrained from scratch, especially for Latin, using an harmonized and big harmonized Latin lemmatized corpus comprising more than 6 million tokens, all assigned a universal part-to-speech tag with common lemmatization criteria and covering a wide diachronic span, because when you deal with Latin, it's always a problem, the Latin you are dealing with, because as you remember, maybe in Eva Latin, we made a number of different subtasks for lemmatization and part-to-speech tagging. One was classical Latin with classical Latin, one was cross-time task, classical Latin versus medieval Latin, and one was cross-genre subtask, which was prose versus poetry, because this affects a lot the accuracy rates of the tools. So now let's use the tool. Here it is. So, and let me make a test with a text by Cicero taken from the Latin library, using, for instance, the Prof. Flacco, and I just copy-paste the first sentence or the first paragraph of the text. And I say process. So what happens here? You will see 3 colors. In green are reported the words, the tokens, that have an exact match with the lemma bank. So there are 69 tokens that have an exact match. What does it mean? It means that, for instance, honoris is linked to the lemma honor. This means that honoris was found, there is a lemma for honoris in the lemma bank, which is honor noun, and there is only one. It's not ambiguous. So the green ones are the tokens that are linked to only one lemma in the lemma bank. And then you have here all information about the lemma. So honor is a masculine third declension noun, and so on. And there is also some information from the lexical resources connected to that lemma in LiLa. So for instance, honor has a polarity positive. The value is 1. Then there are these 5 ambiguous matches, because every time you link a lemmatized resource to the lemma bank, you have 3 classes. Exact matches, so those tokens that have a lemma that corresponds exactly to one lemma in the lemma bank. Ambiguous matches, tokens that have a lemma that corresponds to more than one lemma in the lemma bank. And then no matches, tokens whose lemma is not there in the lemma bank. We have a big lemma bank, but it's not fully covering all the lexicon of Latin. So let's focus on the 5 ambiguous match. So for instance, depellebam. If I click here, I see that the lemma is depello, the upos is verb, and then there are 2 depello verbs in the lemma bank. One is this one, depello of the third conjugation, depello depellere, and the other one is depello verb of the first conjugation, depello depellare. So here, the right one is the first one, the third declension, the third conjugation verb. So I choose this one, and the Pellebam becomes green. And then there is populus. Populus is interesting because there are two populus. One of the second declension is a declension, the second declension noun, and the other one is again a second declension noun. So what is the difference? The difference is here in the length of the vowel. So this populus, the one with this URI, has the long O, which is the poplar, so the tree. Instead, in Latin, this other lemma with the short vowel O is the people. So this is the right one here, and I choose it. So once I did my work, so I solved the ambiguous links, and I included the new lemmas in the lemma bank, and there is a specific form to do it now, that I can show you now. You can click on linking. By linking, you provide some metadata about your file, and this linking will build the so-called TTL file, so the turtle file, which is a serialization of RDF. Basically, the turtle file is a file that collects your triples. And your triples is something like the fact that honoris is linked, this specific token is linked to this specific lemma in the lemma bank. And once you have done this, your resource is linked to LiLa. So to sum up, this is the overview of what LiLa is now. So the resources currently connected to LiLa. There are some upcoming connections, as you can see here. We are connecting 2 more tree banks for Latin beyond the Index Domesticus tree bank. 3 big corpora, especially LiLa is a big, very, very big corpus, an important corpus for classical Latin that is much used by classicists. And this is very important for us because one of the objectives of LiLa is to impact the community of classicists and Latinists, which sometimes are skeptical and resistant with using digital corpora and computational tools to process them. Here you see the lexical resources we have built, and currently we have around 30 million triples in the LiLa knowledge base, and by the end of the project we foresee to have some 100 million triples, and I hope that all the system will remain active until the end, and most of all after the end of the project. And I will share with you the slides, and each of these, in this slide, each of the names here can be linked and will send you to the URI of this specific resource in the LiLa Lemma bank. So you can see the different visualizations. And of course, we have also a query interface for the Lemma bank. And that's it. Thank you very much again for the invitation, and I hope that you enjoyed the talk. Thank you very much.
Thank you.